Otago University research revives dry aging of meat. Dry aging meat concentrates the flavor. Rob Tipper reports on a scientist who is working on an electrifying new aspect. Meat researchers at the University of Otago are reviving an ancient technique to age and tenderize meat by exploring new technologies to make the process more efficient for commercial meat processors. Daniel Adeswamunger, a PhD student in the Department of Food Science at Otago, won an award for his presentation of research into dry aging of meat at an international meat science conference recently in Ireland. The award was presented by Ireland's Minister of Agriculture Michael Greed and conference chair Dr. Declan Troy in recognition of the excellence of Munger's research, which was presented to delegates at the 63rd International Congress of Meat Science and Technology Conference in Cork. It was a really good opportunity to get my work accepted for a presentation there and great to have my research acknowledged at an international level, he said. Munger, who is originally from Zimbabwe, has a 3-year PhD scholarship from the University of Otago and is working in partnership with AgResearch to build on previous research by meat scientists from both institutions. Dry aging of meat is a process done under critically low controlled ambient conditions of temperature and airflow to enhance unique and desirable flavors in red meat. The process can take anything from a few weeks to several months. Munger is exploring the combination of novel techniques, using a pulse electric field and manipulation of aging conditions at relative humidity in chiller chambers to enhance and hasten meat tenderization. The pulse electric field, PEF, treatment is a newer technique that has been used in beef processing but has not been used before in tenderizing venison, which is the focus of Munger's doctoral research. With a pulse electric field, we expose meat to short pulses of high voltage between electrodes, providing the electricity which disrupts the cell membrane, increases cell permeability and hastens the breakdown of proteins. Proteolysis, during aging that contributes to meat tenderization, he said. If we can manipulate the humidity, air velocity and combine with pulse electric field treatments, it can hasten the whole process of dry aging meat and tenderization. You do lose a bit of weight from drip loss, but that is compensated by the concentration of flavors, so when consumers buy the meat they are buying a premium product. Research trials to date have used different treatments of low, medium and high pulse electric field treatments and aging meat for 21 days at different relative humidities to find the sweet point. This is the first time PEF treatments have ever been applied to venison, and we are the first researchers to attempt to combine that with dry aging, so it is quite a novel field, he said. While his work builds on previous research on beef by meat scientists at the University of Otago and AgResearch, his findings on dry aging of venison are applicable to any red meats, although there may be variations in how each meat is treated. We're trying to find the optimum conditions for ideal meat aging so we still maintain high quality, hasten the process of tenderization, and at the same time investigate where those conditions are optimum for lipid spoilage. In the previous research for his master's degree, Wang applied some novel spectroscopic techniques using nuclear magnetic resonance to monitor subtle differences in levels of lipid oxidation in meat. Unsaturated fatty acids in meat are liable to oxidation that causes meat to spoil and can generate some potentially undesirable products, he says. Researchers need to monitor those levels to optimize meat quality. He is hoping to revive dry aging techniques to process meat, which he believes could be used by meat processors on a large commercial scale without slowing down throughput of plants. Pulse electric field techniques are very safe, he says, and can easily be introduced by the meat industry with very low running costs after the initial setup expense. Speeding up the process of tenderizing and aging meat by using new technology could increase turnover, meaning processors won't have to store product for long periods to achieve higher returns. The technology could also be used to enhance the tenderness of lower-value cuts of meat, improving the returns to producers and maximizing the value of meat exports. It's really exciting. It's something I could see the industry applying, Munger says. It's just another step to add value to the refrigerated and chilled products we already have. It would be really good for our whole meat industry if we can add value to our product before we export it. Markets in Japan and China, where New Zealand meat exports already rate highly, and some parts of Europe, particularly Italy and Spain, have a big appetite for dry-aged meat. Dry aging has been a successful process used at a very small scale by some high-end restaurants and specialty outlets to meet the needs of consumers who prefer this unique product. Munger came to New Zealand in 2009 and his passion for food science drew him to the University of Otago, where he completed his undergraduate and master's degrees. The quality of the meat science and lipochemistry research at Otago and the international standing of his supervisors encouraged him to specialize in these fields. Some of the work we have done has shown some really exciting results, but we still have to do some work, so watch this space, he says. A keen hunter and meat lover, he joined the New Zealand Deerstalkers Association Dunedin branch and in his spare time loves to get out in the hills to hunt deer.